Okay. So this for the Facebook followers. This is Dave's Data Analytic channel. It's time for our 8 p.m. Stroll through the book R for Data Science by Hadley Wickham. All right. And I was just saying we're basically using the method by this guy right here. And his whole point is you go online, you get the book for free online, you go page by page, chapter by chapter, do some exercises through the entire book. And if you do one chapter a week, it'll take you 24 weeks to do it. If you do two chapters a week, it'll take you 12 to 13 weeks to do it. Okay? And at the end of this thing, you will know you will have a pretty good foundation of R for data analytics. Okay? And you will also have enough understanding to begin to create an online portfolio of case studies that help you get a job. Okay? So anyway, so we got our book, and also just mention again real briefly for those who came in late, you can find the answer key on GitHub. Oh, by the way, if you don't have a GitHub account set up, I suggest you stop, pause the video, and set up a GitHub account. Okay? Come to R, come to GitHub, type for R for data science. Okay? Here's the source code to the book. Don't worry about that. But come down here and either clone this repository or simply download it. And this is the answer key for chapter by chapter, okay? All right. So now you can either download this or simply look at it here, okay? Because this is and between these two resources, you will learn data science. Now, I have in the past used this type of method before a few years ago. That's how I learned to do Bash shell scripting, and for Unix, I got O'Reilly's book on Bash shell, and I worked page by page through the book for probably half the book, and I learned quite a bit, honestly, and you will. Now, obviously, the younger they are, the quicker you're going to learn. So some of you, like if you're like me, may want to go back tomorrow and just review the text and see it in the code just to make sure you understand it. Okay. So now let's get on with the show. Now, it's like we say, you probably go back and review the first introduction and data visualization because if you're just starting out, you need to go back at some point in the next 24 hours and go through the data visualization chapter number 3 and look at the sample code also because that's really where he starts from. Okay, now let's take a look at chapter 4, which says workflow basic works. Now you can see that this is a fairly short chapter, so that's okay. You now have some experience running our code. We didn't give you many details, but you obviously figured out the basics, and you wouldn't throw this book away in frustrations. Frustration is natural when you start programming in R, because it's such a stickler for punctuation, and even one chapter out of place will cause it to complain. Even one character out of place. But while you could expect to be a little frustrated, take comfort in that it's both typical and temporary. It happens to everyone, and the only way to get over it is to keep trying. He's absolutely right. The whole concept of a learning hump, a learning curve is absolutely true, even with a language that's easy to learn as R. Okay? Let me just open up my book here. Okay, and here's my answer key over here. You can see I actually created a R for Data Science chapter 3, but I'm not really completing all the exercises. Again, you could come over here, okay, and retype all this code, and you would learn a lot. And that's what I did with the Bash. I literally went through and retyped the code. And I just mentioned when I first started to learn R, I started with a guy called David Longer's text, and I went through it and I typed every single line of his code. Okay. Now learn, you'll learn quite a bit. Okay. You may not understand why something works, but you'll certainly learn quite a bit about our programming. So that's why ideally you should do both. Okay. You should understand the answer key, and you should. So now we're over to what are we over to? We're over to 4, right? Hmm, that's interesting. Okay. Now, you experience punctuation. We'll clear out of mind. Temporary, it is temporary. Yes, there is a hump. It happens to everyone, and the only way to get over it is to keep trying. Okay. I've also say sometimes you may want to skip a section and go on to something else if you don't understand it. Okay. Don't become bogged down on individual issues. Before you go any further, let's make sure you have a solid foundation in running our code and that you know about some of the most useful R features, R Studio features. Coding basics. Okay. Let's review some basics we've so far omitted in the interest of getting you plotting as quickly as possible. You can use R as a calculator. 1 divided by 100 is 30. 1 divided by 200 is 30. That's 0.15. Okay. 59 plus 73 plus 2 divided by 3 equals 44. Pi divided by 2 equals 1. You can create new objects with the left arrow, the dash and left arrow, okay? 3 times this is 12. So if you do that, you type x then, okay? So we can say here, it's interesting that he's using this here. This is more like a notebook than our markdown. So anyway, what he's saying here is this. You can say x equals, okay? Then do x, and that's 6. X divided by 2, okay? And so forth. It's a calculator, okay? Now, all R statements where you create objects, assignment statements have to have the same form. Value assigned to this object over here. When reading that code says object name gets value in your head. When reading that code saying object gets the value in your head, you will make lots of assignments, and the left there is the plain is a pain to type. Okay. Uh, you can also use equals, but the preferred method is this one right here, okay? And plain is a pain to type. Don't be lazy and use equals, okay? It will work, but it will cause confusion later. Instead, use the R Studio keyboard shortcut, Alt plus and Alt minus, really. Well, the trouble with that is Alt plus is way up here. Oops. Hmm. That's interesting. Let me zoom back in here a little bit. There. That's interesting. Let's try this again over here. See what he's saying over here. He's saying Alt plus. Maybe I was doing Alt. Okay, I'm doing Alt plus. Okay, there you go. So you can say Alt minus. Okay? And there you go. That's your shortcut. Alt plus, Alt minus. Oh, so this is Alt. This doesn't mean Alt plus sign minus sign. This means like this this means you want to hit the Alt plus the minus key at the same time. Okay, one more time. This so we make sure we get that. Okay, Alt and the minus key. Huh? Alt and the minus key. Very good. All right. Shortcuts are always fun to use, right? Notice that RStudio automatically surrounds with spaces, which is good coding and formatting practice. Code is miserable to read on a good day. So give your eyes a break and use spaces. 4.2. Okay. What's in a name? Object names must start with a letter and can only contain letters, numbers, and oops. You want object names to be descriptive, So you'll need a convention for multiple words. We recommend snake's case, where you separate the lowercase words with underscore. That's quite true. But excuse me, any one of these will work with a possible exception of this here. I use snake case. I'm not sure why it's called snake case, but it is. Other people use camel case. Capitalizing the numbers. Um, some people. I want to suggest that you don't use periods. Okay. Okay. Um, periods. Sometimes periods in column names can cause problems. Okay. That's all I'm going to say at this point. I suggest, honestly, probably this method up here is probably the best. What I would suggest at this point. Okay. We'll come back to code style later in functions. You can inspect an object by typing its name. Make another assignment. This is a really long name. Holy smoke, what happened there? And there you have it. Okay. Now, David Robertson, one of my main data gurus, is he uses this method all the time. Okay. To inspect this object, try out RStudio's completion feature. Type this and then press tab. This is a really good. It's actually very typical in programming, IDE programming environments, but it's very helpful. I mean, it works with commands, and it works as you saw here with objects. An object being a vector, or an object containing is an object containing. Objects are things like vectors or data frames or matrices that contain data. Okay, it's just a data object. Okay, oops, you made a mistake. This is really long. Should have a value of 3.5, not 5.5. Oh no, not again. Use another keyboard shortcut to fix it. Type this, then press Command Control I, up arrow. Oh, Command Control. That didn't work. What happens if we do Control up arrow? I suppose that's what he's talking about. All the command. Okay, so we just saw. Let's do that one more time. Control up arrow, and here's all of our commands. So now we can come up here like this. Okay, you could probably come here like this now. Now, so what's the code to go to the end of the line? Let's see something. This will list the commands, and you've typed the start letters. Use the arrow keys to navigate, and then press the enter key to return the command. Change 2.5 to 3.5. Okay, so we can come back over here now and change that. Then we can do this. And there we are. Okay. Now, I am going to mention, if I haven't mentioned, that this session is going to be a little shorter tonight. I'm not even sure how much we're going to do at this point. Oops, you made a mistake. This is a really long name. Type this and do this here. And now, Make another assignment. Two to the power of 3 is 8. Because it's 2 times 2 is 4, and 4, 5. 4 times is 8, right? So it's 2, 2, 2. 2 times 2 is 4, and 4 times 2 is 8. Good. Let's try to inspect it. Okay, the trouble is because we left off the S, okay? There is an implied contract between you and R. It will do the tedious computations for you, but in return, you must be completely precise in your instructions. Typos, I'm actually going to post this to a, come over here real quick and do something. There. Okay. Just thought I'd throw that up there for people. Okay. Case matters. R has a large collection of built-in functions, okay, that are called like this. Function name, argument equals val1, argue2 equals this. Okay? Let's try using the sequence function, which makes regular sequences of numbers, and while we're at it, learn more useful features of RStudio. Type SE, hit the tab. Okay? Hit the tab. A pop-up will show you possible completion. Specify by hitting Q. You know, it's important to understand that, keep in mind that R is a statistical language, is written by statisticians for statisticians. So any statistical function you can think of is probably already built in. Okay, and this stuff here is just a basic R. You know, the only so far all we used is ggplot2. Everything else has been standard installation, out of the box installation of our programming. Okay, so now. So let's do this again then, shall we? So again, you could do seek date, seek default, seek init, so forth. Seek, generate irregular sequences. Seek is a standard generic with a default method. Seek init is a primitive which can be much faster, but it also restrictions. Okay, so there we go. Now we got that. Okay, so press F1 to get the details in the lower left pane. Okay, let's try some. Oops. Let's do this. So F1 may not work here because of Windows. Let's see. Okay. So this doesn't seem to want to work. Okay. Okay. So he's saying that you should be able to, let's see, complete there. Notice that the floating tooltip that pops up reminds you of the function arguments and possible and purpose. If you want to more help, press F1 and get more details. Okay. I can't get that to work, but all you have to do is, okay, and you find it. That's the normal way of doing it, using the question mark, okay? Press tab once more and when you've selected the function you want. RStudio will add matching opening and closing parentheses. Type the argument 1, 10, hit return. One. So now we just created a sequence of numbers. Type this code. Now, type this code and notice you get a similar assistance with the paired quotation marks. Notice the use of the shortcut there. Okay. Quotation marks and parentheses must always come in pairs. Okay. RStudio does its best to help you, but it's still possible to mess up and end up with a mismatched. If this happens, R will show you a continuation character. Okay. So let's do this. Let's do Alt minus. Oops. Oh, that doesn't work. Okay. Honestly, no, I didn't know about the escape function. Interestingly enough. Okay. This tells R that you're waiting for more input. It doesn't think you've done. It doesn't think you're done yet. Usually, usually that means you've forgotten to either a quote or a right parentheses. This happens all the time. Okay, so look for that magic plus sign. Okay, either add the missing pair or press escape to avoid the expression and try again. If you make an assignment, you don't get to see the value. You're then tempted to immediately double check the results. Okay. One, two, three. So I guess linked out means divided up into five numbers. Suppose we said link 3, 1, 1.5, 2, 2.5. Okay, good. This common action can be shortened by surrounding the assignment with parentheses, which causes the assignment to print screen immediately. Now, I've actually didn't know about this for a long time, to be perfectly honest. But let's come back up here. Place the parentheses around this side. Okay. Of course, you could probably say why. Right? There you go. Okay. So that's helpful. I'm not sure, normally you probably don't want to do that. Well, you could. I mean, well, no. You'll know when it's time to use it, okay? now, now look at your environment in the upper right-hand pane. Okay? Okay. So, we're almost clear to the end of chapter 1. Now, why does this code not work? Does this work? So that must mean there's something misspelled here then. Did I misspell something? Oh wow. Okay. Well, now here's the advantage. What's interesting here, I never saw this before, no, honestly. Uh, R here showed me the difference between between the variable and this. Notice the highlighted I. This looks like a 1 maybe. Okay. Oh wow. So what is that? Is it a 1? Now, I've never noticed that before either. Okay? I've never noticed that level of highlighting before myself. So you can see the difference here. This is I, this is a 1. Okay? Although in my font, the 1 is much bigger. Okay? Tweak each of the following R commands to run them correctly. So we'll go to Tidyverse, run. Oh, wait a minute here. Here we go. Okay, the trouble is here. That should be data. And this is what? Filter. Okay. So filter is spelled wrong. Oh, yeah. So it should be diamonds. Okay, good. What's this? Alt-Shift K. Okay, that gives you a keyboard shortcut. Okay, good. Tools. Keyboard shortcut helps. Okay, good. Hmm. I'll be back in one moment. Okay, I'm back. I'm back. Make sure this is working here now. Testing. Okay, good. Okay, back over here we go. So that's a very short section 2. Now we get to do some more fun stuff. Now, exactly how much of this stuff I'm really going to do tonight? There's 8 parts to it, 7 parts to it. Oh, I don't know. Add new variables with mutate. You know, there's 7 sections. 8. Maybe we'll just go to, I don't know, section 3 or 4, depending on the exercises. Okay, so let's just take a look here at this, okay? Okay, now, visualization is an important tool for insight generation, but it's rare that you get the data exactly in the right form you need. Often you will need, this is chapter 4 in the book. This is chapter 4 in the online version. And now this is interesting. Where's data transformation? Okay, data transformation with dplyr. This doesn't say dplyr, so okay. So in the printed book, this is chapter 3, if you're trying to follow along, okay? So anyway, visualization is an important tool. As an important tool for insight generation, but it's rare that you get the data in exactly the right form you need. Often you will need to create some new variables or summaries, or maybe just want to rename the variables or reorder the observations in order to make the data a little easier to work with. You'll learn how to do all that and more in this chapter, which will teach you how to transform your data using dplyr package. dplyr is part of Tidyverse. I'm sure I stated in a moment here, okay? It's part of Tidyverse, okay? And a new data set on flights departing from New York City in 2013. Prerequisites. In this chapter, we're going to focus on how to use dplyr package. Another core member of the Tidyverse. We'll illustrate the key ideas using data from a New York City's flight package. To use ggplot2 to help us understand the data, let's do the following things. See, this says 4, but it's actually 5. Okay. You know what? He hasn't introduced our markdown, so let's just come up here. Okay. And let's create an empty R script. And let's just call it, let's call it, okay. Of course, the current chapters, whatever chapters we're actually working on at the time. Okay, so now we got this. So we're going to load these 2 things. That's, yeah, we can do something like this. Oh, crap. What happened there? Okay. So we'll load these 2 packages here. We're done. Notice one thing. You click the run button, it runs the current line. But it automatically goes to the next line. So let's run the next line also, okay? Prerequisites. Take careful note of the conflict messages that appear that are printed when you load the Tidyverse. Conflict messages? Conflict messages? I mean, it's interesting. I didn't actually see any Normally, you will see conflict messages, but it may be because it's already loaded once before. Take careful note of the conflict messages that printed when you loaded the Tidyverse. It tells you that dplyr overwrites some functions in base R. If you want to use the base R functions of these functions, often loading after loading dplyr, you'll need to use their full names: package name or library name, colon colon, and the name of the function. Okay. Now, so let's get started here. To explore the basic information, the basic data manipulation verbs of dplyr, we'll use the New York City 113 flights database, okay? This data frame contains all 336,776 flights that departed from New York City in 2013. The data comes from the U.S. Bureau of Transportation Statistics and is documented in flights. So let's take a quick look at the here's our help section, okay? Data frame with columns. Year. Notice I just the broom says delete everything in the pane. Okay, so the broom just deleted all the variables and stuff, objects from the environment. Okay, format: year, month, day, date of departure, departure time, arrival time, the actual departure and arrival time, scheduled departure time, scheduled arrival time. Pretty obvious. Departure delay, arrival delay. Carrier, two-letter carrier variation. See airlines to get the name. Flight number, tail number, the plane tail number. See planes for additional metadata. Origin, destination, airtime, distance, hours, minutes, time of scheduled departure broken into hours and minutes. Time, hour, scheduled date, and hour of the flight as a POSIX number. Okay, so there we go. And let's just type flights up here. You notice carefully how I was testing you there. I was testing to make sure you're paying attention, so I misspelled flights. And here we have it, okay? This is a Tibble, of course. If you look down here, there's 36,766 more rows with 12 variables. And this lists all the variables down here. It also lists the type of variable. This is an integer or number. This is a double digit. Okay. This is a character, integer, character, double, 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 and time. Okay. This is a time function here. Okay. Now, you might notice that this data frame prints a little differently from the other data frames you might have used in the past. It only shows the first few rows and all the columns that can fit on one screen. To see the whole data set, you can run view flights, which will open the data set in the R viewer. Okay, let's do that. And here that is. Now I want you to notice over here, the actual data frame, the flights, doesn't actually appear, okay, in the environment, which is kind of interesting. But here's the whole data frame and all the columns. Okay, lots and lots of data. Okay. Now, it prints differently because it's a Tibble. Tibbles are data frames, but slightly tweaked to work better with Tidyverse. For now, you don't need to worry about the differences. We'll come back to Tibbles with great detail and wrangling. Okay? You might also have noticed the row of 3 or 4-letter abbreviations under column names. Int is integers, is the stands for doubles or real numbers. Characters and a date plus a timestamp. Okay. Now there are three other common types of variables that aren't used in this data set. There's a logical or Boolean, true and false. A factor stands for factor, which R uses to represent categorical variables, right? With fixed values. The key phrase there is with fixed values. Okay, keep that phrase in mind. And date stands for dates. Dplyr basics. Now you think ggplot is fun. Wait till you get your hands on dplyr. Okay. Wait till you get your hands on dplyr. You'll never go back to base arguing. Well, except for a few cases. Okay. In this chapter, you're going to learn 5 key dplyr functions that allow you to solve the vast majority of your data manipulation channel. You notice this really is true. I would say between the chapter on data visualization and this chapter on data wrangling, you're going to learn about 80% of what you need to know. Okay. Unfortunately, the old 80-20 rule says it takes 80% of the time. It takes 20% of the time to do 80% of the problem, and 80% of your time goes to solve the 20% of the remainder 20%. So, but you'll use the plotting functions and these dplyr functions over and over again. Okay, so get used to it. The vast majority of your data manipulation challenge. I want to read it because this is such an important sentence. I want to read this more. I want you to read this one more time. In this chapter, you're going to learn the 5 key data dplyr functions that allow you to solve the vast majority of your data manipulation challenges. Okay, but of course there is more. Pick observations by their values using filter. Reorder rows, arrange. Pick variables by their name, select. Create new variables with functions of existing variables, mutate. Collapse many values down to a single summary, summarize. These can all be used in conjunction with the group by, which hasn't been introduced yet. Okay, which changes the scope of each function from operating on an entire data set to operating on its group by group. Okay, these 6 functions provide the verb for the language of data manipulation. Okay. Now, if some of you have worked with SQL before, these functions here should look familiar because they should arrange. Filter is a where statement, arrange is a sort by, order by, select is select, mutate would be say the as function, right? Use the as function to rename a variable. Summarize is summarize and group by are of course the group by should look familiar, right? And summarize is use group by to create summary numbers in SQL, right? These 6 functions provide the verbs for the language of data manipulation. All verbs work similarly. The first argument is the data frame. The subsequent arguments describe what to do with the data frame using variable names without quotes. The result is this is very important. The result is a new data frame. Okay. Together, these properties make it easy to chain together multiple simple steps to achieve a complex result. Let's dive in and see how these verbs work. Okay. So here we go. Filter allows you to subset observations based on their values. The first argument is the name of the data frame. Okay. For example, we can select all the flights from January 1st with this command. Okay. This command right here. So let's come over here. Let's just do that. Now there actually is a second way to do this. So I'm sure I'll get back to it later on. Month, day. So let's see what happens here now. Let me run this. Okay, so here's the flights for January 1st, okay? Data frame, column name or variable column name. Notice the double equal sign, okay? That's a as opposed to the single equal. So we explain that here, okay? When you run that line of code, dplyr executes the filter operations and returns a new data frame. Dplyr functions never modify their inputs. So if you want to save the result, you'll need to use the assignment operator. Oh, let's just come back over here. Oh, look at that. Notice that there's still no variables up here, even though we're accessing the data frame, there's no variables up here. But this command is going to change that. Now watch closely. Now we just created our own data frame, and there it is. We can also display it down here. All right. Now, R either prints out the results or saves them to a variable. If you want to do both, you can wrap the assignment in parentheses. Okay, so let's come down here, do this. Well, let's just retype the whole thing, just for practice. I hope you noticed the use of the right? Is this right? Okay, so let's do this. So this should create a new data frame called December 25, and it should also print out the results if it works correctly. And it works. Now, in all honesty, I don't think I've ever seen this particular type of wrapping in quotes actually done before. Okay, because normally you would normally you would. Well, if you were in a script, what would we do here? I mean, normally you would assign it to another data frame name and then print that out. Okay, but nonetheless, this is something to keep in mind. Okay. Comparisons. Now we get to something interesting, don't we? Now we get to something interesting. Use filters effectively. You have to know how to select the observations that you want to use using the comparison operators. R provides a standard suite: greater than, equal to, less than, equal to, not equal to, and equal. When starting out in R, the easiest mistake is to use equals instead of double equal. When testing for equality, when this happens, you get an informative error. So what's our informative error say down here? Problem with filter input 1. Input is name. This usually means that you used instead of this. Did you mean? Yes, actually, yes, we did mean that. Yes. Here we go. Okay. There's another common problem you might encounter when using floating point numbers that results may surprise you. So square root of 2, false. So what does 1 divided by 49 actually equal? Suppose we say this. It's still 1. Okay. Computers use finite precision arithmetic. They obviously can't store the infinite number of digits. So remember that every number you see is an approximation. Okay, instead of relying on use near. Now, I've never heard of the near function before. So once again, just a reminder of how we got all these built-in functions we do nothing about. So what is the square root of? Hmm. Hmm. That's interesting. Okay. Logical operators. Okay. Multiple arguments to filter are combined with and every expression must be true in order for the row to be included in the output. For other types of combinations, you'll need to use Boolean operators yourself. Think and is and bar is and this is not. Figure 5.1 shows a complete set of Boolean operations. Y and not X, X, Y or X or Y, X and Y, X or XY. So I guess those mean the same things. Again, I've seen reference to the XOR, but I have never really used it actually myself. X and not Y and Y. Okay. The following code finds all the flights that departed in November or December. So let's just type this up here then. You said November or December. So this should be November or December, right? Of course, we can't actually see it because it then created a new field. There we go, the 12th also, okay? Excellent. The order of operation doesn't work like English. You can't write flights, which you might literally translate into find all flights that departed in November or December. Instead, it finds all the months that equal 11 or 12, an expression that evaluates to true. In a numeric context like here, true becomes 1, so this finds all the flights in January, not November or December. This is quite confusing. Yes, it is. A useful shorthand for this problem is the end function, okay? Very helpful, yeah. This will select every row where X is one of as one of the, is one of the values in Y. We could we could we could use it to rewrite the code above. Okay, so let's type this. See if this works. Yep, it certainly does. Sometimes you can simplify complicated uh, subsetting. Remember the De Morgan law. X is not X is the same as. For example, if you wanted to find the flights that weren't delayed on arrival or departure by more than 2 hours, you can use either of the following two filters. Not equals to delay. Yeah, that's true. Okay, yep. Understand that? Again, so this means arrival delay not greater than 120. So therefore, it's got to be less than 120. Okay, good. As well as the ampersand, the plus sign, and sign, the sign. Also has double as this and this. Don't use them here. You'll learn about those should when you should use in the conditional executions. Okay, where are we here? This is 523. Hmm. You know what we might do is we might just this because discipline is important in this field. Okay, discipline is very important, and so we may just finish up to 524 this evening. Okay, through the exercises because I had a very long session this afternoon. Okay. Whenever you start using complicated multi-part expressions in filter, consider making them explicit variables instead. This makes it much easier to check your work. Okay. Missing values. Boom, 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 boom. One important feature of R is that can make comparisons tricky are missing values. or NAs, not available. NA represents an unknown value, or so missing values are contiguous. Almost any operation involving unknown value will also be unknown. So we got NA is greater than 5 NA, 10 is equal to NA, NA, and so forth, okay? The most confusing result is this one here. It's easy to understand why this is true with a bit more context. Let X be Mary's age. Okay, we don't know how old she is. Okay, let John's age, let Y equals John's age. We don't know how old he is. Are John and Mary the same age? We don't know. Was that helpful for you? Okay. If you want to determine if a value is missing, okay, value is missing, use the is in A. Okay. Filter includes rows where the condition is true. Okay. It excludes both false and NA values. If you want to preserve missing values, ask for them explicitly. Tibble is this. So let's do this. Okay, so now we got an NA embedded in there. Filter Okay. Let's do a filter. Oh man, I lost my place. Oh, jeez. Okay, data transformation. We're still working on filtering with rows, right? Comparisons, missing values. Okay. So we're almost to the end of tonight's session, okay? Well, I saw a lot of views on some of my work. I'm not really sure how many people were actually watching the whole thing. Okay. So we got a Tibble. Let's do isn't a X or X greater than 1. What if we run this by itself? Or X is greater than 1. Okay, good. Suppose we said exercises. Oh man. Okay. Find all the flights that had an arrival delay of 2 or more hours. So now we get to a little bit of fun stuff here. Let's just delete all this. Delete all this. So we're going to say arrival delay of more than 2 hours. Okay, let's take a look here. Okay. Who flew to Houston? Oh, this is interesting. So this is destination, right? Where's destination? Destination. So, and Houston. Okay, good. Let's see. All the flights that were operated by United, America, or Delta. So we're going to change this to carriers. United. Now I hope you're following along and typing this code as I am, because you know the old adage is is repetition is the mother of all learning. Absolutely true. It's not so much a knowledge of our program, it is being able to simply recall various syntaxes and stuff like that, the actual structure of the code. So let's try this here now, shall we? Hmm. Okay. So what are the carrier? Okay. What's the airlines? So we're saying United, UA. We should know these. It's so common. Did you catch that? Did you catch you had to go back to the help section and find out how to find out the two two codes? You know the thing about these, some of these we should just know from practical experience. Everybody knows that American Airlines is AA, and Delta DL. So we had to make the leap from the full name of the airlines to the two-letter abbreviation. Okay. Now, one thing we could have done, of course, is this. Okay, I'll just say this: we could have done something like this. Okay, we could have. Well, no, we could have used a filter stream with to pull out the abbreviations. Okay, we could have done a filter on name. Okay, and got it that way. But again, so what do? We came back to the help section, right? And it said carrier, see the airline to get the name, and then we ran this. Okay, so again, you have to be able to put one and one together sometime. Oh, hey Juan, how you doing, friend? I'm just working through some another half a chapter of my R for Data Science book. I'm doing good, friend. How was class today? Okay, let's do this. Seven, 8, and 9. Now there are other ways we can do this. We could say, we could say, greater than 6 and less than 9. Okay, but this is a short thing, and you really You really find that this end function really is incredibly useful. Okay, and 9. Okay, so let's take a look at this first one. Okay, we can come over here and say, but didn't leave late. So the departure delay could be equal 0, maybe. Hmm. But didn't leave late. Well, there's obviously departure time, but that doesn't really tell us anything. I mean, are there zeros? So when we say departure delay, Let's take a look at Chapter 5. Is this Chapter 5 we want here again? Yes, it is. Okay, maybe he's working on 4. Okay, what we'd have to look at over here is the flights data. Again. Well, the question is, but didn't leave late. So we could say, you know, let's see how this works. Right? Because these flights here didn't depart late. As a matter of fact, they departed early. Okay. We're delayed by at least an hour, but made up over 30 minutes in flight. Okay. Well, he's calling New York flights here, but he's not really. This really. Let's see. Package arm GG stance. So, but made up over 30 minutes in flight. Okay, departure time, scheduled departure time. Well, we'll be perfectly honest. Let's see, but made up over 30 minutes in flight. Well, it could be arrival delay, right? So if they made up over 30 minutes in flight, So he left late. Let's do something. Let's take a look at a second. Let's try this over here one more time. Where are we here? This is exercise 524. Okay, I'm going to be perfectly honest. I'm not really sure what the answer is to this question here. I mean, it's because it's not arrival time. You know what? I'm going to be perfectly honest. I'm not really sure what that answer is. Let's move on down to the next question. Okay, so let's say What is midnight? So if departure time is 1, that's 2400, right? Okay, I'm going to say oh, let's do this. Okay. Well, they can't be both. Probably. How many flights have missed departure time? Well, yeah, you could use between. I'm not sure how the so I could say so I could say although I don't think that's correct. I'm not sure that's actually correct because we don't actually want between. This should work, but that's next. But this is between, so it means it's not including. Okay, this. So maybe between does in fact include. 184. Okay. Now, have how many flights have a missing departure time? What other variables are missing? What might these rows represent? I'm not really sure. Why is innate? Okay, you know what? I'm not sure the answer to this last question here, but anyway, uh, anyone, I'm going to call it a night this evening. I'm going to come back tomorrow evening. We'll pick up with 521. Okay? Well, this says 53. Okay, we'll come back tomorrow night, folks, and we'll pick it up with chapter 5.3. This is the online number. So anyway, Juan, we'll catch you later on also. Okay, friend? Good night.